This is calculus homework number 45, problem number 5. Question says a Norman window is constructed by joining a semicircle to the top of an ordinary rectangular window, excuse me. There's the picture. Find the dimensions of a Norman window of maximum area if the total perimeter is 16 feet. So we know the perimeter is going to be 3 sides of the rectangle. Let me see if I can draw this down. So the perimeter is 16, and that's going to consist of this side, this side, this side, and then the semicircle. Okay, so it's not going to include that last side. And I tried to draw in here, the radius of that semicircle is 1/2 x, because we're calling this side x. But they want to maximize the area. So the area is going to be the area of the rectangle, length times width, which is x times y, and the area added to the area of the semicircle. So area of a circle is pi r squared. A little problem with my pen here. Pi r squared. And, well, what's the radius? It's 1/2 x. And it's a semicircle, so it's half of that. Okay, so it's just half of that. And that's 1/2 pi, 1/2 x squared. So I have um, two variables, because I'm trying to maximize this. I want to get it written as one variable. So I need to come up with another equation. Well, before we come up with that, let's just simplify this a little bit. 1/2 x squared is 1/4 x squared. 1/4 times 1/2 is 1/8. So I want to eventually try to come through and find another equation where I can substitute in y. So let's set up the perimeter. Perimeter is y plus x plus the circumference of a circle, which we know is 2 pi r. But in this case, it's going to be half of that. So it's going to be just pi times r. And I know that the radius is 1/2 x. And I know this whole perimeter is going to be 16. Okay, so let's start following along. So this was the 2 pi r, but it was semicircle, so it was half of that. So we cut that in half. And there's our 1/2 x for the radius. So all we're doing is just simplifying this. Again, that's just going to be pi over 2x. So x plus the 2 y's. And notice again, we're not using this side in our perimeter. And then it's just the half a circle. Okay, and now we know that's equal to 16. Okay, let's get all the x's on one side. So this is all the algebra. We're still working with the perimeter here. Let's solve it for y. Okay, and now once I know what y equals, then I come back up here and I substitute it in. And now my area formula is written in terms of just x. Okay, and now algebra, we go through, distribute the x. Okay, let's not even, yep, before I could have combined like terms with all these x squared, but at the same time, I can just take the derivative. So that's what we do here. Derivative of 8x is 8. 1/2 x squared is just negative x. Minus pi over 2x plus pi over 4x. We want to, in order to optimize, we want to find a maximum min. We set it equal to 0. So let's factor out this negative x, and I'm left with, first of all, let's move the negative 8 over. And so this is what we get for an answer. Now, put that in your calculator. And we could have done some with our calculator up here and found this decimal a little bit earlier, but this is just showing the algebra, how you get that. So 4.481 is the value that makes the derivative of the area, which is the rate of change. Again, we want to try to find if it's a maximum. So let's do a sign change chart, put in 1 into our derivative, and we find out that's a positive number. And here's the derivative right here. Again, you can use your calculator to find that's positive. Put in 5 or 10. So hey, it's increasing here, it's decreasing here. Therefore, I have a max. And now I just go back into my original relationship between the x and the y. and I can find out that my y must be equal to 2.240 because I knew, and by original relationship, I knew perimeter was equal to 16. So I can put in what I know for x here and solve for y, or I could do it right here. Either way. So those are the dimensions, and that's what the question asks. Find the dimensions of the Norman window that's going to give the maximum area. All right? Hopefully that helps you get ready for the quiz.